Today we are going to be reviewing trigonometry. So we're going to refresh your memory on all things trigonometry related. Okay, then this is just trig, so this is just triangle trig and a little bit of sector and area. So it's all a part of the same unit.
Oh, so like the sine, cosine, that's that circular function.
Like the graphs of them, yes, and then the equations, that's circular functions. We're going to do that on Friday. So today we're doing mostly triangle-based stuff, and then your sectors. Okay. So pretty much these are all your main concepts. Okay, so we're just going to kind of start at the beginning, go all the way down. All right. First off, Pythagorean Theorem. What is it?
A squared plus b squared equals c squared.
A squared plus b squared equals c squared. And when do you use it?
Finding a hypotenuse.
You can use it to find a hypotenuse of a right triangle, but you can also use it to find any side, really and truly. As long as you know but it has to be of a right triangle. And you have to know the other two sides. So as long as you know 2 out of the 3 sides, you can use Pythagorean Theorem to find that third side, but again, it has to be a right triangle. Okay, so it has to be a right triangle. Now, SOHCAHTOA was the little thing to remember when you are looking for either a side or an angle, again, in a right triangle. Of course, S. Keep going. Sine is opposite over hypotenuse. The C. Cosine. Adjacent over hypotenuse. And the T. Tangent opposite over adjacent. Again, this applies to right triangles. Okay, that is when it is used. It is used again to find any side or any angle in a right triangle. Okay, so let's say that you were given this and you're looking for that angle theta. You have to remember that you would need to use what?
That would be. Well, we're searching for the angle, right?
We are looking for the angle. So what trig function would I use here?
Yeah,
it would be the tangent of your angle, 3 over 4, and because I'm looking for an angle, I need to make sure to do the what?
Inverse of tangent.
Inverse of tangent. You always do inverse when you are looking for an angle, and of course, if let's say you were actually given the angle and you're looking for a side length, then it's just the regular sine, cosine, and tangent. Making sure that when you are doing SOHCAHTOA, you want to be in what mode?
Degrees.
You want to make sure that you are in degree mode. We'll make sure that you're in degree mode. Now the unit circle. You haven't forgotten the unit circle, have you?
No.
Okay, everybody have a marker in a felt?
Oh yeah.
Okay, on your desk right now, I want you guys to do the unit circle.
Thingies.
You want to make sure that you include your degrees, your radians, and your ordered pairs on your unit circle. So remember, the unit circle was comprised of degrees, radians, and ordered pairs, okay? These were this is your respective unit circle. Remember, all your ordered pairs on the inside of the quadrants were always over 2. There's different patterns with that, but the main thing is if you knew what quadrant 1 was, then you knew what the other quadrants ordered pairs were, because the corresponding points that relate to that rectangle, all of them were the same all the way through. So as long as you, again, knew the first quadrant, you knew all the other quadrants as well. Just making sure that in your second quadrant, your x's are negative. Third quadrant, x and y are negative. And then in the fourth quadrant, x's are positive and the y's are negative.
Also, that's just a nice square aesthetic.
Exactly. Okay. So yes, please do not forget about your unit circle. Okay, do not forget about your unit circle. That was, you first learned about that then in the trigonometry.
I've got the unit.
Okay. Let's see, compass points. What's at the top?
North.
East, south, and west.
There you go. Okay, so those are your different compass points. These were used in your application type problems. Along with 3-figure bearing. Remember, 3-figure bearings always came from the north direction going
south.
East.
So which way? Because I can go south either going clockwise or counterclockwise.
Clockwise.
Going clockwise. Remember, bearings always went from the north direction, going clockwise, and it's 3 figure bearings. So that means you needed to have basically 3 numbers. So if the number was less than 100, you always put in a 0 placeholder to represent, like 94 degrees, a bearing of 094. Okay.
So what if it's like 094 south? Like, how would you do that?
So that's a compass point, not a bearing. So if something was like north or like south 20 degrees east, they would use that to indicate a particular angle. So that would be from the south direction heading east 20 degrees, that would be this right here. That would be 20. Okay? So what would that correspond to as a bearing? As a bearing, that would be 160 degrees as a bearing. Okay? So that's the difference between compass points, which would be something like this. This would be compass points, and then this here would be a bearing.
A bearing always starts at north.
It always comes from the north direction heading clockwise to wherever the angle is.
So what's a bearing of 120 degrees?
So if it's a
That would be 120 degrees north clockwise down to the south.
going clockwise, yes. So if you look at it, if you have a point, say you have a ship that's sailing on a 120 degree bearing. So then wherever the ship starts out from, draw like an imaginary north line, and then go 120 degrees heading clockwise. That would be 120 degrees.
So if you wanted to go northwest, it would be 300.
So if he wanted to go northwest, it would be something in between 270 and 360. Yeah, so a boat could go on a bearing of 226 degrees. So let's say the bearing was 226 degrees. Again, wherever the boat is starting from, draw that imaginary north line. We know that 226 is bigger than 180, but less than 270. So then that would be heading in this direction. All of this would be 226 degrees. Because if I kind of make my little, there you go. Does that make sense? One other concept before we get into sine rule, cosine rule, is angles of elevation and depression. I don't know why I don't have that in there because that was like the very first of the application problems that you guys dealt with. Remember, angles of elevation and depression always come from a eye level, and eye level is always
Straight,
horizontal.
parallel.
they're straight. It is horizontal. So if this is my eye, and I'm looking. Okay, I always look at a horizontal. And then if I look up, that's my angle of elevation. But if I look down, that's my angle of depression. But no matter what, it needs to come from a horizontal line going down, horizontal line going up. Questions up to this point? Do you remember this?
I remember the depression part.
Oh, Jesus. All right. What about sine rule? When do you use sine rule? Not side angle side.
It's A over sine and sine over.
Okay, when you know
It's
two
sine
sides and there's
sine
an
over
angle
eight.
between the two of them.
Now, if you have a two sides and an angle between, that's actually going to be cosine rule. Yes.
Dang, I was right before the wrong thing.
So, like, if you have this is 7, this is 6, and you know this is 30 degrees, that right there was you used cosine rule for that. So let's do cosine rule because cosine rule there were only 2 stipulations when you used it. Side angle side was one of them. What was the other one? Side. That's when you knew all 3 sides. Okay, so this is 4, 6, 8. That's when you would use that's when you had cosine rule. Okay. Any other situation, angle side angle, side angle. That's when you would use the sine rule. Okay, those are the situations. Anything else? So angle, side, side, angle. That's when you use the sine rule. Now remember with sine rule, there was also the ambiguous case. Do y'all remember the?
Where you had to draw the second triangle.
Yes.
Where you had to draw the second triangle.
You know, I just decided the fact that that's on the test. I'm gonna take my points and just move
But no, remember that this was easy to detect. This was easy to detect. Okay, so side angle, and a lot of times it always like a lot of these types of problems where it's like it asks you to find the obtuse angle, and when you did the sine rule, you end up finding an acute angle. You would subtract it from 180. Okay, so let's take a look at an example with the ambiguous case right here. Okay, you have a side angle situation where the side across from your 40-degree side across from your angle is smaller than the other one. Okay, so remember to solve this triangle out, what will be the first thing? Would be the easiest thing to find at this point?
The adjacent side from AC.
How so?
Okay.
Sine rule.
Sine rule to find angle C.
Well, then that's the thing, okay? So this would then be a sine rule one. We would actually have to find angle C first, because the only way to find AC is if I knew the angle across from it, and I don't know that one.
Oh, I can't use SOHCAHTOA. This is not right.
And I can't use SOHCAHTOA because it's not a right triangle. So I would need to find angle C. Now, sine rule and cosine rule are both in your reference book. They are both in your reference book. Okay? But who happens to remember what it is?
Sine A
That's a good question.
Sine A over little a.
Equals sine B over little b. And then you cross multiply.
Mm-hmm. So this is what's in your reference booklet. Okay, but in this case, since I'm looking for angle C, I'm going to use the A part and the C part. So I'll plug in, that's the sine of 40 over 14 equals the sine of big C over 20. How do I solve?
Oh, you just do cross multiplication? No.
I cross multiply.
Yeah, oh, okay.
So calculators out.
Yes.
And then what would I do? Divide by 14. And then I would take the inverse.
Why would you do that?
You want to make sure you're in what mode?
Degrees.
Degrees. What'd you guys get for angle C?
66.7, 366.
66.7. Now, because I said this is a particular ambiguous case, did you find the other angle C?
Oh, we're supposed to find that other angle.
Mhm. And remember, you get it by doing 180 minus the angle C that you found. What's 180 minus the 66.7 number that you got? 15.3? 113.3 and some change. So this is where you would have a second triangle. So this one, A is still 40 degrees. C is now 113.3, but of course, you know, we would use 3 significant figures, so it's really 113. Side C is still 20. Side A is still 14. We'll know for sure if we have a second triangle, if when I add these two angles that are in this second triangle, if I add them and they end up being less than 180. So, this is how I get angle C in triangle 2. So then what's angle B in triangle 2? 27?
If you're not doing the round up.
Okay, well, I still need 3 significant figures since it's
Okay.
26.7. Okay, so then I would do 180 minus 40 minus that 113.3 number. So then I would get 26.7 degrees for that second angle B.
Okay.
That's the second angle C?
Mm-hmm. And remember, you always check for ambiguous case in a side angle situation, and you find that second triangle after you find the first angle. So once you find the first angle, which was angle C in this case, you do 180 minus that to get the potential angle C in the second triangle, and then you'll find angle B from there.
But where is that triangle coming from?
Okay, so and I try to draw it in that particular way so you can see it. In the first triangle that's labeled with the purple, you have one of them. But realize that I can move side BC closer to angle A.
So you scooted it.
I scooted it in, but I never changed the length of side BC. I just was able to relocate it to a point that was closer to A.
What?
So then, of course, you would need to find the remaining angle B in this particular case over here by, again, doing 180 minus the other two. So what is that?
73.3.
73.3?
Yeah.
And then, of course, you will find your remaining side B's by doing another sine rule. Okay? So I definitely want to make sure to go over that one when it came to those non-right triangles. Again, this is used for non-right triangles. SOHCAHTOA is used for right triangles. But if you have a non-right triangle, you use either sine rule or cosine rule. Questions?
No.
Area of a triangle is also part of this. What's the formula for an area of a triangle?
Half of. Okay, I'm done.
Yes, now that's a normal right
That's
triangle,
the easy
1/2
one.
base times height. What is the area formula?
BC sine A?
It's the Heron's formula.
1/2 BC sine A.
We never went over Heron's formula in this class.
Oh, really?
Yes.
Get out of here.
Heron's formula is another way to find the area of a triangle if you know all three sides.
I wish I was that complex, man.
But this is the
It's
formula
not
that's in your reference booklet. I think it's BC sine A. It could be 1/2 AC sine B. It could be 1/2 AC.
Corresponding.
Yes, pretty much. And this is used in these types of situations where you know two sides and included angle, you can find the area of a triangle. All of these from this point and up, your calculator should be in degree mode. Of course, in the circle, it has its radians and things like that. But when it came to arcs and sectors, you want to make sure that your angles that you're working with are in radians. Because those formulas that were in the reference booklet to find arc length and area of a sector, they were with your angle being a radian. So arc length was equal to your radius times your angle, and the area of your sector was equal to 1/2 r squared theta. Again, theta needed to be in radian. It needed to be a radian. So if they gave it to you as a degree, you needed to convert. Okay?
So is this one a
To
degree?
radius. Huh?
Is this one a degree?
Yes. So everything above this line needed to be in degree. So all of this was degree. But these two down here, when it came to arcs and sectors, those two needed to be in radian.
And we just do that by multiplying by pi and divide by 180.
Exactly. Okay, so just in case you forgot to go from a degree to a radian, you multiply by.
I predict the future, as you can see, my mind. Okay, I got it.
How do you go?
My 5 seconds.
Yeah.
of-
How do I go from radian to degree?
You
180
multiply
over
by
9.
180 and divide by pi.
Okay, and that was I seldom. Okay, almost never did you ever go from radian to degree. But again, if you need to go from degree to radian, you multiply by pi over 180. And like I said, arc length and areas of sectors needed to be in radian. So looking at this one, it's to state the value of theta in degrees. Because it's an equilateral triangle, all the angles are equal, so that means they have to be how many degrees? 60 degrees, which means that it'll be how many radians?
Pi over 3.
Very good. Now you need the radian measure because it actually states the length of the arc. The formula for arc length is,
Radius multiplied by the radian.
okay, and so what's the radius?
1.
And the angle is?
Pi over 3.
So your arc length is
Pi over 3.
Arc length should always be in radians, right?
always.
Got it.
Same thing with area of a sector, because it actually states the area of this sector, OAP, so it's basically asking to state the area of this, which again is the formula 1/2 r squared theta. So that's 1/2 1 squared times pi over 3. What's your area?
Pi over
6.
6.
Pi over 6. There you go. Okay?
Get in my way.
Let's do this one. This one you are able to use your calculator.
Calculator,
Let's try this one.
buddy.
So for this particular problem, because this is a rectangular prism, that means that all of these angles are
Right triangles.
right triangles, okay? Every single one of them. So in this triangle over here, DCG, this is a 3, 4,
5.
5 triangle, so this side is 5. in this one A, E, D. This other right triangle, this side is 6. What's AE?
3.
3. So then you have to use Pythagorean Theorem to find ED, which was what?
3 square root of 5.
3 square root of 5, so the square root of 45 originally?
Yes.
Okay, cool. So then you have this one up here at the top, this FEG, or you, to be honest, you really could use any one. FG was how long?
6.
6. EF was
4.
4.
Yeah,
So then this becomes the square root of what?
52, right?
2. Yeah, which is 2 square root of 13.
Okay. Now, because I now have all these sides now for this particular triangle, that's asking me to find angle EDG. I'm looking for this angle right here. So what am I going to use to figure that out?
Cosine.
I'm going to use cosine rule. Cosine of angle EDG is equal to,
85.3.
how'd you get that? What? Set it up.
I got
Oh, I put in the decimals, so
square root of
45
Square root of 45
plus 5.
squared
Plus
plus 5 squared minus
2 times.
square root of 52 squared all
Then
over
you go to
2
the top.
square root of 45 times the square root of 5. You type that in, then you take the
Oh,
square root of that.
Not the square root.
Inverse cosine. So that.
inverse of cosine.
So
If you leave it as the radicals, that ends up being 45 plus 25 minus 52. So then it'll be a nice number over a fraction over something else. So what is that?
yeah,
74.4. You got 80 something.
I did it wrong. I didn't square it, but after I went through and I squared, I got 61.5.
Should be 71 and some change. So let's see.
Well,
So I have, remember, second y equals, option 1 takes you to the fraction. Square root of 45 squared is 45, plus 5 squared, which is 25, minus 52. Square roots and squares cancel out. 2 times the square root of 45 times 5. I need to do the cosine inverse. What mode do I need to be in?
Degree.
Degree. So let me change that. So cosine inverse of that answer, 74 point.
Well,
Questions?
it's
How
a
can we
self-fulfilling prophecy I made here, boys. And girl and number one in between, 'cause I don't care.
Anything on Lucas?
All right, let's do this one.
Wait, if I got this right.
So Anki and Lucas are considering buying a block of land. The land agent supplies them with a given accurate sketch. Find the area of the property, and your answer in meters squared. This property is in the shape of what?
Trapezoid.
No.
2 triangles.
We've gone over
2 triangles. Not a trapezoid. 2 triangles.
Wrong.
Okay. So to find the area of the property, you probably want to find the area of one triangle.
And then add it to the other one.
Yes, and so for the triangle ABD, you already can figure out the area because you're already given 2 sides, 120 and 125, and the included angle, which is 75. Okay? But for the other triangle BCD, you do not know BD, so you need to figure out what BD is. Then you'll multiply that by 90, and then you'll be able to do the sine of 30 degrees for that one. How do I find BD?
Okay, so basically what we're going to need to do is, what I forgot.
Cosine rule, because that is the side opposite of the, because we do know the angle opposite of the side that we're
so
looking
get
for.
125 squared plus 120 squared minus 2, both of them multiplied together, cosine of 75 degrees.
Make sure you're in what mode?
Degrees.
Degrees, and then of course taking the square root at the end, and you'll get your value.
Which is around 149 point something change.
So that's what you plug in there, and then you'll basically perform the sum of those 2 triangle areas.
3 sig fig, right?
wait a second.
3 significant figures, yes. Did anybody get an answer?
I did.
What you get?
10,600.
10,600.
I got 10,600.
Because you rounded three significant figures, yes?
Yep. And that 0 is a significant figure.
Yeah, and that 0 that's in between the 1 and the 6 is a significant figure.
Oh, I got 4,081.
4,081? Okay, let's see.
One of the answers is not similar.
I got 344,000.
One of these
I'm
is
shot.
not like the other.
I'm just
One
kidding.
of these just doesn't
Okay,
puzzle.
so why is
Yes, so this one should have been this. So three significant figures would be this.
How the heck?
Double check that.
Andrew was playing wrong answers only.
No. I don't even know how I got that. At least I broke my streak of not getting things correct.
Not getting things correct?
Mathematics?
Yep.
Alright, let's do this
Right.
one and then we'll do one more.
Now, soulmate.
The hardest part of this one is the drawing of the picture. This one does deal with bearings. Family in Germany drives 140 kilometers per hour for 45 minutes on a bearing of 32 degrees. So remember when I talked about bearings, remember you're starting from a particular point, okay? And then that means you'll be heading in the north direction from that point going which way?
East,
30.
which is to the right.
So it's heading to the clockwise?
Yes, clock.
Okay, I worry when you say east that you might be potentially, be a little distorted there. Okay, but we have 130 degrees, 32 degrees bearing. Remember, it's three-figure bearing, so you need a zero placeholder if it's less than 100. And they travel 140 kilometers per hour for 45 minutes. Now, that's not a full hour. So how far did they travel?
105 kilometers.
What he
Yeah.
said.
How'd you get that?
I
Multiply
put
by
140 over
40.
60 and then I multiplied that by 45.
Okay.
I did 140 times 45 over 60.
Yeah.
I did 0.75.
You do that too.
Yeah, I did
Distance
0.75.
equals 3 times time, right?
Mm-hmm.
Yeah, fraction.
But I mean,
Basically, you did the same
but
thing.
we're,
But
we know, yeah. So, but it's 45 minutes. So that's in retrospect to an hour. So that should have been times 45 minutes out of the full hour. Because it's per hour.
Right?
So 105, you said?
105.
Yes, ma'am.
Then you'll get to a particular point. Okay? That's how far they got. Now, from that point, it says then they go another distance for 40 minutes on a different bearing. So again, coming from the north direction, heading clockwise, 317 as their bearing. So that actually means I need to move this picture down because I'll keep that there. It's fine. Because again, you're heading in the clockwise direction. 317 degrees is between 270 and 360. So this is 317 degrees. Okay? Does everybody see that?
Yes.
And they went 180 kilometers per hour for 40 minutes. So that'd be 180, 40 over 60. So how far? 120 kilometers. Okay? So now it says find the distance and bearing of the car from the starting point. So we are looking for this distance from this point to this point. That's what we're looking for. And it just so happens that my picture drew, it's almost like a perfect straight line, but that's not always the case. Now, my question is, in order to be able to do this, I need to know what this angle is right here.
Yes.
What is it?
So,
Is it 1.5?
How'd you get that?
I got 73.
How'd you get that?
Well, I did, since you can do ulterior, interior angles from like the 32, it's like from the bearing, it's like 32 on the other side.
Okay, where would 32 be? Help me out.
If you like drew the cross, it's kind of like in between, like the line of the triangle and that line. Yeah,
So between here and here, this is
32.
32. Again, alternate interior angles, very good. North lines are parallel. Parallel lines create alternate interior angles. So if this angle here is 32 or 32 degrees, that means its alternate interior angle is also 32.
And then can you find the gap between 317 and the 360 on top and the difference of the 180 spacing?
You talking about finding this point right here?
Yeah, like find the gap, find the angle of that.
You could. there's several different ways to come about finding this angle. You could easily say, well, since I know that this is 180 degrees, I can add 180 to 32 and subtract that from 317. I can figure out what this gap is by doing 360 minus 317 and then, do the whole 180 thing. You can do it a few different ways. But do you guys agree with Andrew that's 73?
That's what I got.
Yeah, it would be around
Okay, so after doing the math, it's actually not 73, but
105.
105?
Apparently.
This is why I hate bearings.
I did it.
All right, good stuff.
That's
So,
a big
by
one.
adding 180 and 32 together, you get 212. And since we know that that pink curvature line has to be 317, we subtract those, and then that's how we get 105.
Apparently.
So now we have a side, angle, side. So we would do, we do cosine rule to figure out the distance. So that's 105 squared plus 120 squared minus 2 times 105 times 120 cosine 105. And of course, to find the side length, what we have to do at the end. You have to take the square root.
Side roll.
So someone trying to figure out that side length. So you guys should be figuring this out. Let's go.
Why did you just call them?
Because if one guy's gonna be taken down by that coronavirus, we're all gonna go down.
Girl.
No, I'm 17.
What'd you guys get for your distance? 179? So 179 kilometers. So that's how far they've gone. Now it's asked you to find the bearing of the car from the starting point. Okay? So the bearing of the car from the starting point. So that basically means that if I originally just went straight from the starting point, which is here, to the actual end point, it's asking me to find that bearing. Okay?
Wow.
Asking me to figure out what that bearing is. How would you do that?
It's just 317.
What?
Because that's the last bearing you were on.
And this might help a little bit if I do it this way. If I shorten this up, because it actually wouldn't go to there. So what we just found was this right here. Sorry, that's x. That distance. So what if I wanted to go straight there? I basically am looking for this bearing right here. That's what I want to find. That little distance right there.
Now you just made 200 kilometers shorter than 105.
I don't even know anymore.
How do I find that? What do I need to do?
Good question.
Okay, so
wait,
let's just
90?
find that side of x first.
90 went,
We did. We found that to be 179.
So
Oh,
132.
okay, I got it.
Alternate.
I feel like it's simple, but
It is.
Is it just another triangle?
Hmm?
Is it a triangle?
It's not another triangle. You already have a triangle that you're working with. That 32 degrees is not the 32 degrees in that triangle that we've developed. That 32 represents the bearing from the north direction heading.
Oh, so you find the angle in the triangle and subtract it.
Yes, you need to figure out what this angle is right here. Okay, and once you figure out what this green angle is, you subtract it from the 32 to figure out what that small degree angle is there.
oh,
Okay, so how do you find this angle right here in green?
The sine rule.
The sine rule, because now you know the side across from the 105 degree angle. It should still be sitting in your calculator. So that's going to be the sine of 105 over that 179 number equals sine of, let's just say theta, over which side? 120. I will cross multiply, divide by the 179 number, and then I have to take the
Inverse of
Inverse
sine.
sine.
inverse of sine to find that angle inside of my triangle.
120.
I'm assuming you took a 10 minutes, right?
I did.
Stop remembering.
It literally says on the board.
Yes, well, Anglo. William already did it, so he's already 2 steps ahead of you. But you got bamboozled because he's.
What did you get?
I got error.
40.4.
Why would you put that?
Yeah, 40.4.
40.4 degrees. So this kind of actually lets us know that in this particular drawing, and let me fix it so you can have the visual. So by fixing up this picture, we can see that that angle inside of that triangle, where the opposite side is 179 kilometers, is actually bigger than that initial bearing that we had. And so that means that this piece, this part that was in the triangle, this green part, was a little bit bigger than that 32-degree angle, which went from the north direction and then over to create to that orange line. So then to find the actual bearing, remember bearings head in the clockwise direction from the north. So one last drawing on this picture. I basically need to figure out what. There's a very fine line here. I don't think you guys can probably see it from the back. I basically need to figure out what that angle is there. There's a small sliver that's in between that's not accounted for. What is that small bit? What is that small bit right here?
360 minus the 40.4.
But that 40.4 includes that 32.
So 40.4 minus 32.
So what's 40.4 minus 32?
8.4. Yeah.
Sure it's 8.4?
Well, I just added 8 to it, and then add 0.4, and then boom, 8.4.
8.4 to 8.43 rounded.
Oh, I
Okay.
forgot that was.
So
not-
8.43. So that's that little small sliver. So what would be my bearing? Because it won't be that 8.43.
It would just be
It'd be
360
0,
minus that, right?
It'd be 360 minus that. Because that 8.43 number is that distance in between, and we need that blue curve, which is definitely a lot bigger than 8 degrees. So what is that?
350.57.
351.57, so 352 degrees. That would be your bearing.
That was quite the question.
Did we get this one?
All that happens.
So in this particular problem, you're told that O is the center of the circle and AT is tangent to the circle T. Tangent means that it forms a
Right angle.
right angle, a right triangle where the radius is 6. So you know this is 6, and then you also know that AO is 12. Now you can easily to find the area of the shaded region, you basically need to find the area of the
Entire
triangle.
Subtract one of the others.
Sector.
And you have to find the area of the triangle, and you have to subtract the area of the sector. Now, to find the area of the triangle,
Base times height divided by 2, but we don't know the height, so we're just gonna get.
we can find it though by doing what?
It's a radio.
The Pythagorean Theorem, right? 6 squared plus AT squared is equal to 12 squared. 6 squared is,
36.
and 12 squared is.
144. 144 minus 36. 108, which simplifies down to.
Ooh.
3 square root. 6 square root 3 and excusez-moi.
Okay, so this does simplify to be 6 square root of 3. Now, you've seen this before. 6 square root of 3, 12.
It's the special right triangle.
It is a special right triangle. Which special right triangle?
The 30, 60, 90.
The side across from the shortest side is 30. The side across from the 6 root 3 is the 60. So you do have the angle inside there. So the area of the triangle is going to be 1/2 base times height minus 1/2 your radius squared times your angle, which needs to be a what? And what's 6 degrees as a radian? Pi over 3. So this becomes, what's half of 6? 3 times 6. So this becomes 18 root 3. What's 6 squared?
36.
What's half of 36?
18.
And what's 18 divided by 3?
6.
Dude, we're so close to this.
Wait. Okay, I know that we got the
so
area
far
of
away,
the
Griffin.
triangle for the first part, but the second half, that's the sector area?
Yes, because remember, it's the formula 1/2
Oh,
r
sorry.
squared theta.
I confused it with the area arc length.
Yes.
That was
Okay.
this.
So, this is just a few problems that dealt with trigonometry, but the main things that I want to make sure that you guys are fully aware of is all of this that we covered at the very beginning. This is what is comprised of your trigonometry unit. Pythagorean Theorem, SOHCAHTOA, unit circle, bearings, sine rule, cosine rule, area of a triangle, arcs, sectors, angles, elevation, and depression. Okay?